Now we got into the hard part. That's the notation. Since the model is really complicated, we have some kind of strange notations, at least to most of the undergraduate students. That's a little bit complicated. First, you understand what we are dealing is a discrete time model. That means we only observe like every 100 milliseconds or every 1 second, depends. A GPS, you need to get the signal back and forth like 70 milliseconds. So usually you get a couple of 100 milliseconds as 1 tick. So the time, you call it T0, the start point, T1, the first calculation, all the way to Tn, you terminate your calculation. Well, then the next concept, that's the key concept, of course, for any robotic navigation, it's called state vector. State vector tell you where you are at tk. So the shorthand is just a vector, put a little k, means your time. To make it easier, you can write as 0, 1, 2, kn. So this each tick is the time unit. Could be 1 second, could be 100 milliseconds. That's your choice of the program. So this is the notation. The state variable, to make it simple, back to the truck example. The truck example, I might need 4 variables. X, Y stand for the position of the local coordinate, and then I have this Vx, Vy, the speed along the x direction. Maybe x is the north direction, y is the east direction. Then the velocity of north direction, velocity of east direction. That's a state variable. But that's not enough. I need to put the little k here. What does that mean if I put a 2 here? Or sometimes some other give this way, put the 2 this way. That means you are in the second tick time. So if you don't understand this, nothing you could understand. So that's the state vector. Whenever you design a robotic navigation, that's how you start it. You always start to design your state vector. For example, my AUV, autonomous underwater vehicle, I need 9 at least design parameters, probably 14, some other x, y, z, vx, vy, vz, and the 3 angles, the pitch angle, yarding angle, and the rolling angle, and the time bias, and the drift, all those things. So that's pretty complicated in itself. Well, now the shorthand, we don't always write it this way. We just put the little k. This is a capital, x is a vector, and this is the actual state vector. Well, what is the actual state vector? We don't know. In reality, we are all our calculations try to estimate that. We don't know, but the convention, we just write into a capital letter, put a little k there. So another convention is this k line k What does that mean? Why I want to make that complicated? Well, that's a statistic convention. When you do any probability estimate, we use that convention. One word is called a posteriori state estimate. That means it's after you do the calculation. And this K is the condition, this K is your current time. And then the same for the P, which is the covariance matrix. And if I put a 2K here, that usually is the posteriori error convergence matrix. And then we need to look at the input, memory, and the output. And this calculation only have one step memory. That means the compute program only remember the immediate present state. That state is the observation of last calculation, which is the state variable. When you put a little hat on the top, that simply tell you it's an estimate. It's not the real one. We told you the real one we do not know. And at the time tk minus 1, that means the previous time. And then this k minus 1 is the final result of the last calculation. So this is the input from the next cycle. Well, all this complication come with this k and the k minus 1. What does that mean? That's the priori knowledge of the state. The priori knowledge of the state. And this is the estimate based on the prediction phase. And then this is the covariance in the prediction phase. That's an a priori knowledge of the state. The whole computation of the gamma filter will output a posteriori estimate. The posteriori estimate is this. And the k minus 1 now become k and k. Now you need to put a number. Maybe this k equals 3, and then this one is going to be x. The input is 2, 2, and the output will be x 3, 3. No, 3, 3. That's how you write it. Well, understand this, then you can read the material yourself.